Alright guys, I'm sure you saw my computer monitor video for the Flyback, how to make one driver from the computer monitor. Well, today we're doing one with the television, and I thought that I'd show just another one, just so other people who have actually a television. The setup is slightly different. Here's the innards of a television, of course. Here's the Flyback. We'll be needing this. As you can see, it's all discharged and everything. I could touch it. It's going to need to blowtorch that at the bottom to get it removed. Looks like it just has these things that hold it in place. These things here. And it also has that's pretty much it. So it's got a couple of heat sinks here, I noticed. We're going to be needing a few resistors. First one is we're going to be needing somewhere around like a 220 ohm and a 22 ohm resistor. Now looking on this board, I haven't really come across any yet. It's a big resistor, but we can't use that because that's a 3.3 kilo ohm resistor. So I'll look around for two of those resistors, and we want one. It's about 220 ohms, and well, there's 220 ohm in there. You can use that. You're also looking for a 22 ohm, and that looks like it's a 22 ohm right there. All right, so we got our two resistors. Might want a diode. I believe I see one in there. And you're going to want a capacitor that's around a nanofarad, so 102, something like that. I'm sure we'll find one of these on the board. There's no problem. And that's pretty much. Well, we also need the transistor. As you can see, the transistor, I can already tell, is that one right there. And if you look what it says D2102. I already looked that up. It's a horizontal deflection transistor for television, so that's what's going to power the circuit. You might want to take a heatsink off there too. So I'm going to blowtorch off all these parts right now, and then I'll show them to you once I get them off. Alright. And so here we have all our parts. So first we have a 220 ohm resistor, 22 ohm resistor, our transistor, which is a D212 or D2102. It's horizontal deflection transistor. Your transistor will probably have a similar code on it with a letter and then some numbers. Basically, it's the biggest transistor on your board. It goes base, collector, emitter. There's the 3 pins. Next, you're going to need the diode. It's basically a fast recovery rectifier diode, like a UF1 or UF4007, something like that. But it's basically, I just found it on the board here. I could tell. You know, it'll work just fine for our purposes. Here's a capacitor. It's a 222, which is a 22 nanofarad, or no, it's a 2.2 nanofarad actually. That's I think it's like 3 kilovolts, so that's cool. Heatsink and screws, and of course our Flyback transformer. Now we just have to we have space to wind our own coils, but I'm just going to use the ones built in. So next we have to identify the coils on the Flyback, and I'm going to do that right now out here. Okay, so for this part we're going to identify the coils on the Flyback. As you can see, there are lots of pins, and it's really not that hard. Basically, you need a multimeter. You want to set it to the lowest ohms setting, which mine is 200 ohms, and if you you might also have a fancier multimeter for continuity testing. You want to do that. Here, you can see if you touch them together, it goes off. It goes from 0 up to like a couple hundredths of an ohm. Now you're looking for on this. It's going to be below 1 ohm. Most likely anywhere from 0.4 to 1 ohm for the primary coils. And they're going to be the first few pins. So already pin 1 and 2, we're getting a resistance of about 0.8 now. So I mean, this is obviously it's got to be the primary coil. So we're gonna just yeah, you see 0.8, that's 0.9 now. That's definitely the primary coil because it has the highest resistance. I mean, on our first try. Well, we'll test a few other pins. You can see there's some, that could be another primary coil there. It possibly could be 2. I would just use the first 2 pins that you find, though. And none of the other pins should have contact, you see. And then also pins 2 and 3. So it's safe to say that this group of pins here, the primary coils, I'm going to be using pins 1 and 2 as the primary coil, though. Alright, so now we'll keep moving on. So We'll start at pin 4 now. Move on, see if we can figure out the feedback coils. And here's another. Let's try this again. Okay, that was a bit weird. Might take a little bit because my multimeter is a little bit funky, but alright, so alright, I'm just gonna move on. Alright, so now we're at pin 5. Let's see if we can get any coils here. On to pin 6. Pin 7. Pin 8. Nope. Okay, so there we're getting something, but so I think that's safe to say that's a feedback coil because it's around 0.2, 0.3 even. Yeah, so got pins 1, 2, pins 1, 2, and then 8 and 10. So we got the primary coil, which is a resistance for me of about 0.8 ohms, and pins 8 and 10, which is the feedback coil, which is a resistance of, come on, you can do it. Yep, which has a resistance of about alright, has a resistance about 0.3 ohms. Alright, so we have our coils now. All you gotta do is solder wires to them and you should be good to go. And then we'll set up the diagram. So I hooked everything up in this previous schematic, and I'm using this power supply. If you haven't seen it, it's an 18-volt power supply. It's basically a 12-volt transformer, 3 amps from Radio Shack rectified with some diodes I had laying around, and a capacitor, 470 microfarads. And that goes into, it comes out as 18 volts DC at about 3 amps. So I don't know if this is going to work. I don't know if it's the right, because you're going to have to change between the primary coil and the feedback coil. You might have to switch a couple around to get it just right. But nonetheless, I'm going to try it and see how it works. See if it works. And I think I got it on the first try. Alright, so here's the high voltage cable. And that looks like it's high voltage ground. Alright, there's a lot of corona. Zoom in on this. Alright, right there. Try getting just a little closer. There you go. Try to get that to focus. Not sure if it will. Let's get that to focus. There we go. Alright. Let's unplug this. Always discharge it. It will hold a charge in the secondary, but since it's a television flyback, it probably won't hold that much of a charge. Now, one thing I do have to point out, as I smell burning here, the resistors for this, these are obviously only 1 watt resistors, and right now they're screeching hot, especially the 22 ohm resistor. That's going to be the one, like the transistor's cool, but the resistors are the things that are going to be taking the heat here. So you're going to want to try to find resistors that are more than 1 watt. I mean, if you use like if you use really small resistors, let's say, I don't have one laying around, but let's say you use like a 4th watt or half watt resistors, those aren't going to work. You need like 1 watt or more. Preferably these gray ones, which I think are cement, because those will not catch on fire. Those are also the ones that are found in the television circuits and computer monitor circuits. So that's basically the most basic flyback driver you can get. If you want to protect your transistor, or if you want to power it with more voltage, all you do is add a diode in reverse bias between the emitter and the collector, and also a capacitor as well. I'm not going to add those now. I'll let you guys do that. You can experiment with this with different voltages. One other example, out of another out of another television, I got this transistor. It's a 2SD871. This is also a type of horizontal deflection transistor. So they're going to either look like that, or they're going to look like that, the square one. Alright, so thanks for watching, and have fun playing with high voltage. Be safe though.